My name is Mohammad Laiq Siddiqui, the father of Holophase. Episode 5, Part 6. Let's take a deep breath and do this properly. In this part of the Holophase journey, we're going to try something quietly outrageous. We're going to use phi and its dimensional echoes to glimpse the shape of the universe itself. Not shape like a balloon or a donut, shape in a deeper sense. How is the rhythm of phi organized from quantum to cosmic scale? How does that organization show up simultaneously as time, space, and motion? And how can we stop staring only at the shadows, time, space, motion, and begin to see the holophase itself and its derivatives? This episode is about that shift of vision. Up to now, we've mostly looked at the expressions of phi, how phi becomes what we call time, how phi becomes what we call space, how phi becomes what we call motion. Now we start training a different kind of eye, to stop mistaking the branches for the tree and to begin seeing phi and its patterns of change as the underlying living structure. This part prepares us for the next episode, where we'll try something even more ambitious, to read the dimensional shadow of phi across scales, and from that, infer the shape of the universe's holophase tree. But first, we need one clean picture. One hidden rhythm, three echoes. Imagine the universe is built from a single, everywhere present rhythm field, phi, the holophase. At every point, phi has a phase angle, where in the cycle it is there, a local rate of change, how that angle is shifting in time and space, a pattern of motion, how features of that phase pattern drift or propagate. You never see phi directly, you only ever see how it changes. From those changes, three big readouts emerge. Time is what you get when you ask, how fast is phi turning if I stay here and let things evolve? Clocks are just instruments that count how many cycles of phi happen between two events. 2. Space is what you get when you ask, how does phi change when I move there instead of staying here? Rulers and distances are ways of sampling how phase varies across locations. 3. Motion is what you get when you ask, how do specific features of phi's pattern move through this spatial variation as phi keeps turning? Velocities, trajectories, flows. These are all stories about how phase structures relocate through space as time passes. So in holophase language, time is equal to echo of phi's temporal derivative. Space is equal to echo of phi's spatial derivatives. Motion is equal to echo of how phi's spatio-temporal derivatives line up to make features drift. One underlying object, three different listeners. To make this concrete, let's use an image you can feel. 2. The orchestra and the three listeners. Picture phi as a vast, invisible orchestra, playing one continuous piece of music across the entire universe. This piece has many layers: fast, high notes, slow, deep notes, long, sustained tones, short, sharp pulses. Now imagine three listeners, each with a different bias. Time sits with eyes closed and asks, at this point, right here, how quickly is the music turning over? How rapid is the beat? That's the temporal cadence of phi. Space walks around the hall and asks, How does the tune change as I move? When I go from here to there, how different is the melody? That's the spatial pattern of phi. Motion focuses on features in the sound, say a recurring motif in the violins, and asks, how quickly does that motif travel from one part of the orchestra to another? That's the phase patterns movement, the kinematic echo. Same underlying music, three modes of listening. If you speed up the whole orchestra, time says the beats are closer together. Space says, as I move around, the pattern changes more quickly. The wavelength is tighter. Motion says, those features are sweeping across the orchestra faster. If you slow it down, time, fewer beats per second. Space, broader, slower variation across the whole. Motion, features drift more gently. You never changed the existence of time, space, or motion. You changed fa, and they all responded together. That's the core structural claim. Time, space, and motion are not independent substances. They are three linked echoes of a single underlying phase rhythm. Now let's walk through scales and see how this plays out. Zooming in, falling into the quantum storm. We start where we live, the human band. Your body, your room, your city, your planet, these live in a middle tempo of fa. Seconds, minutes, hours, years feel natural. Meters to kilometers feel intuitive. Walking to airplane speeds feel familiar. Now imagine pressing a cosmic zoom in button. You fall through your skin, into a cell, into a molecule, into an atom, down into the shimmering world of fields and quantum excitations. What happens to phi as you fall? 3.1 Time echo at quantum scale. Processes suddenly happen ridiculously fast. Atomic transitions in trillionths of a second. Ultra-fast laser pulses in femtoseconds. Phase flips at frequencies we struggle even to name. Holophase view. At the quantum floor, phi's local cadence explodes. The phase angle whips around at an almost unimaginable rate. So the time echo becomes extremely fine-grained. Tiny time slices are full of meaningful events. 1 second contains a vast number of phi cycles. If your ordinary sense of time is like a casual heartbeat, quantum phi is like a hummingbird's heart under a strobe light. 3.2 Space echo at quantum scale. Now look at space down here. Structures are tiny. Atomic orbitals, interference fringes, crystal lattice spacings. Holophase view. Phi's spatial gradients are sharp. Move a tiny distance and the phase can change a lot. So the space echo says, small displacements matter. Wavelengths are short. The pattern is densely packed. It's like looking at a hyper-detailed painting. A shift of your head by 1 millimeter reveals a completely new dot pattern. 3.3 Motion echo at quantum scale. And motion? Particles don't stroll. They jitter, tunnel, interfere. Wave packets spread, phase fronts advance. Holophase view. Motion here is how these fine-grained phase features shift as phi races in time and varies in space. Tiny changes in time and position can flip an interference pattern. The motion echo is almost hypersensitive. This is what physicists call high energy. In holophase, that just means very fast phi over very small distances. Energy is a readout of that speed and sharpness, not a separate ingredient. So at the quantum end, phi is like the blazing high-pitched section of the orchestra. Super fast, super fine, incredibly intense. Hold that texture. Now we climb back up. Zooming out. Quantum, human, cosmic. We start in the quantum storm. Ultra-fast phi, tiny distances, and slowly zoom back out. We see atoms forming molecules, molecules forming proteins and cells, cells forming tissues and organisms, organisms forming societies, planets, stars, galaxies, cosmic webs. Something simple but profound happens as we climb. The effective phi rhythm that dominates each scale slows down. Careful. Phi itself contains many frequencies everywhere. But at each scale, a particular band of rhythms matters most. Think of wearing different headphones with built-in filters. One emphasizes bass, you hear slow beats. One emphasizes treble, you hear fine, fast flickers. The music is the same. Your filter changes. Each scale, quantum, human, cosmic, is like a different filter on phi. 4.1 Human Band Mid-Tempo Phi. Back in our everyday world, heartbeats, conversations, walking, driving, weather, seasons. This is the mid-band of phi. Not as frantic as quantum, not as glacial as cosmic. Time echo here. Seconds to years are natural. We build clocks that count mid-frequency phi cycles. Quartz, atomic transitions, mechanical oscillations. Space echo. Structures from micrometers to kilometers dominate our lives. Smaller details blur into material properties. Larger scales blur into landscape and sky. Motion echo. Motion of phi structures like bodies, cars, air masses. Speeds that lie far below light speed, but are right for life and technology. The same phi plays here, but we're listening to its middle register. 4.2 Cosmic Band, the deep bass of phi. Zoom out beyond cities and planets. Planetary systems orbit stars, stars orbit galactic centers, galaxies drift in clusters, clusters trace the cosmic web. Here, the dominant phi rhythms are slow and huge. Timescales, millions to billions of years. Spatial scales, light years to megaparsecs. Motions, giant orbits and expansions that look static on human timescales. Holophase view. At cosmic scales, we're mostly hearing the deep bass of phi, slow, huge waves in phase structure. Time echo. Natural intervals are billions of years. Local processes unfold on such long scales that our whole species is a brief spark. Space echo. Characteristic distances between nearby structures are enormous. Space looks sparse but patterned. Motion echo. Stars and galaxies move quickly in absolute units, but their cycles, orbits, mergers, relaxations are extremely long. So from quantum to cosmic, phi's effective cadence slows, the space echo stretches, the motion echo smooths and broadens. We didn't change universes. We changed which band of phi we care about. 5. The double journey, feeling the spectrum of phi. Let's put both directions together, because this is where we begin to glimpse the shape behind the scenes. 5.1 Upward, quantum, human, cosmic. At the quantum floor, phi is fast and fine. Time echo, tiny ticks. Space echo, tight wavelengths. Motion echo, jittery, sensitive dynamics. At the human band, Phi's mid-range dominates. Time echo, seconds to years. Space echo, meters to thousands of kilometers. Motion echo, everyday flows and velocities. At the cosmic canopy, Phi's low tones rule. Time echo, millions to billions of years. Space echo, light years to cosmic filaments. Slow, majestic, large-scale flows. At each step, nothing fundamentally new is added. We are always reading Fa and its derivatives, but through different windows and resolutions. Time, space, motion stretch or shrink to match the dominant band of Phi. 5.2 Downward. Cosmic, human, quantum. Now run it backwards. Start at cosmic. Phi's effective tempo is slow. Zoom to galactic and stellar. Phi's patterns quicken, structures shrink relative to the whole. Zoom to planetary and human. Phi's midband becomes most relevant. Time accelerates, structures become familiar. Zoom to cellular and molecular. Phi's rhythms get faster, space more granular, motion more turbulent. Zoom to quantum. Phi's high frequency, fine scale structure dominates again. Both journeys tell the same story. The universe is a scale-organized spectrum of Phi's rhythm. Time, space, and motion are three linked ways that spectrum shows itself at each level. This is our first soft answer to what is the dimensional shape of the universe? It is not just 3D space plus 1D time. It is one holophase field with a nested hierarchy of rhythms, read out simultaneously as time, space, and motion at every scale. Now let's switch analogies and deepen the picture. The tree and its shadows. Picture a vast tree growing out of nothing. The trunk is Phi, the holophase itself. One continuous living structure from the deepest roots, quantum, to the highest branches, cosmic. From the base of the trunk, three great branches emerge. One, the time branch, all the rhythms, cycles, durations, rates. Two, the space branch, all the sizes, distances, shapes, geometries. Three, the motion branch, all the velocities, accelerations, flows. As the tree rises, each branch splits into sub-branches. Time, instants, durations, cycles, ages. Space, points, lengths, areas, curvatures. Motion, displacements, velocities, accelerations, higher kinematic orders. And at the tips, leaves. Specific phenomena. A photon emission, a heartbeat, a hurricane, a star's orbit, a galactic collision. Now imagine shining three lights at this tree from different directions. One light creates a time shadow on a wall. It reveals only the temporal aspects of how the tree lives. A second light creates a space shadow, shapes, distances, where branches reach. A third creates a motion shadow, how parts of the tree sway, flex, oscillate. If you only ever saw the shadows, you might think there is a thing called time. Separately, there is a thing called space. Separately, there is a thing called motion. You could build precise theories of each shadow. You could measure them, predict them, apply them. But you would be missing the deeper fact. All three shadows come from one tree. Holophase is that tree. Time, space, and motion are its three great shadow branches. And here is the crucial shift this episode is guiding you towards. Instead of staring only at the shadows and arguing about their properties, we want to start inferring the tree itself, the structure of phi, and the structure of its derivatives. In other words, the real target is not space-time with stuff inside. The real target is the holophase skeleton that throws all three shadows at once. The next episode will use these shadows, across quantum, human, and cosmic scales, to sketch the shape of that skeleton. But before that, we need to see how to treat this as more than poetry. A simple experimental lens, 3 echoes, 1 cause. Even at this gentle, audio-friendly level, Holophase makes a strong, testable claim. Whenever there is a stable rhythm in nature, you should be able to see of it. A time echo, how often something repeats at a point. A space echo, how its pattern is laid out across space. A motion echo, how fast features of that pattern move. All explainable as consequences of one underlying phase pattern. Let's ground that with simple examples. 7.1 Water weights. Think of a long tank of water with a paddle moving up and down at one end. You can adjust the paddle's frequency, how often it pushes. As you dial the frequency up or down, at one fixed point in the tank, the water surface bobs up and down more or less often. That's the how many cycles per second readout. The distance between wave crests, the wavelength, changes with frequency and depth. The spatial pattern tightens or loosens. The crests themselves move across the tank with a certain speed. That speed is tied to both frequency and wavelength. One underlying dial, the driving rhythm, produces 3 coupled changes in time, in space, in motion. Holophase says, this is not just how water behaves, it is a glimpse of a universal pattern. 7.2 Sound and light. A similar thing happens with sound and light. For sound, increased pitch, higher temporal frequency, shorter wavelength in air, speed of sound roughly fixed, time, space, motion linked. For light in vacuum, increased frequency, shorter wavelength, pattern speed, speed of light fixed. Again, time echo, space echo, motion echo are mathematically welded. We are used to these relationships. Holophase takes them seriously as clues. In any regime where we have coherent, repeatable dynamics, time, space, and motion should be coherently explainable as echoes of one phase structure. If we ever find a domain where we can describe time, space, and motion separately, but no consistent phase structure can underlie them, and that failure survives careful checking, then the holophase picture is in trouble. That's our falsifiability hook, even at the conceptual level. 8. From shadows to phi, changing how we look. So far in your life, almost everything, from school physics to everyday language, has trained you to trust the shadows. Time as a separate thing, space as a separate thing, motion as something happening inside that space and time. Holophase is asking you to perform a mental inversion. Stop treating time, space, and motion as ultimate. Treat them as measurements of something deeper. Start seeing every clock, ruler, and speedometer as a particular way of sampling phi, a particular sensitivity to one band of phase behavior. When you hear someone say, everything is energy, let a quiet voice in you answer, no, everything is phase. Energy is one summary number we compute from what phase is doing. And when you think about scales, quantum, human, cosmic, start to hear them as different tempo bands of the same holophase orchestra, each throwing three coupled shadows. Once this switch clicks, something important happens. You no longer think of the universe as a box of stuff in spacetime. You start to think of it as a living phase tree, with time, space, and motion as three interwoven ways that tree shows itself. And crucially, you begin to look through the dimensional shadows to the holophase and its derivatives that generate them. That is exactly the mindset we need for what comes next. Setting up the next episode, reading the tree from its shadows. Up to this point in the audio series, we've done three big things. 1. Dethroned energy as the fundamental substance and reinterpreted it as a phase readout, a tally of how intense phase behavior is in certain windows. 2. Introduced holophase, phi, as the underlying rhythm, a single cyclic order field from which all observables can, in principle, be read. 3. Shown that time, space, and motion are dimensional expressions of phi. Time, echo of phi's temporal derivative, space, echo of phi's spatial derivatives, motion, echo of how phase patterns propagate. In this part, we added one more layer. We walked down into the quantum storm and up into the cosmic canopy, watching how phi's effective rhythm changes with scale. We saw that at each level, time, space, and motion change character together. Fast phi, tiny times, tight spaces, jittery motion. Slow phi, vast times, stretched spaces, gentle, grand motion. We wrapped this in the image of a tree and its shadows, and we began shifting perspective from the shadows back to the tree itself. The next episode will take a deliberate step. We will use the three-dimensional shadows of phi, time, space, and motion across scales, to reconstruct a more precise picture of the holophase tree, and with it, a deeper notion of the shape of the universe. We will ask questions like, how are phi's rhythms arranged from quantum to cosmic? How do those rhythms organize the cascades of change in time, the textures in space, and the bands of possible motion? How can we treat the universe's shape not as a static geometry, but as a pattern of phase dynamics projected into these three dimensions? You can think of it this way. Up to now, we've stood in front of the wall, looking at three colored shadows. Next time, we begin to step behind the wall, to walk around the tree that casts them. We will still use simple language and concrete examples. We will still keep everything testable in spirit. But we will allow ourselves to say, quietly and seriously, we are no longer just describing the behavior of time, space, and motion. We are trying to describe the holophase structure of the universe itself. And that, my friend, is where the holophase journey starts to become not just a reinterpretation of physics, but a genuine attempt to see the skeleton of reality, directly through phi and its derivatives. Let's go there together in the next part.